Hello everyone, let's start with Blockchain Trilemma and solutions to the challenges that we've already studied before in the previous videos, right? So let's come to the Blockchain Trilemma challenges. The first challenge that we have is scalability. So just imagine you're at a shopping mall and on a normal day, the billing counters work just fine. You buy something, you go to the counter, pay for it, and then you're done. But now think about a big festival sale. Diwali is approaching. Suddenly, thousands and thousands of people rush in at once. The counters get overloaded, queues become endless, people start leaving frustrated. That's exactly what happens with blockchains like Bitcoin and Ethereum. Bitcoin, if I talk about the statistical details, it can only process about 7 transactions per second. And Ethereum in its current form manages about 15-30 transactions per second. Now compare this to Visa, which handles over 65,000 transactions per second, right? The gap is huge. This inability to handle large transaction volumes is what we call the scalability problem. But here's the catch right now. See, fixing it isn't easy because we have three main pillars that we need to take care of that go by scalability, decentralization, and security. If you try to make one improve, the other two or one out of the two, they actually go wrong. So, at max, you can get two on three problems rectified. And that is where, fixing it, that is where we understand that fixing it isn't as easy as just adding more counters or speeding up transactions, adding more, counter people. Because blockchains also need to remain secure and decentralized, and these two are the other two pillars that we have in the trilemma. You know what? This is what is actually the trilemma problem. If you try to make the system faster, that is scalability, you try to increase, you might end up giving more control to fewer nodes, which reduces your decentralization. If you focus on decentralization, that okay, I'll keep this as possible decentralized, you may slow the system down, hurting scalability. And if you loosen up security checks just to speed things up, well, the whole network becomes vulnerable. So the trilemma is like trying to keep three plates spinning at the same time: scalability, decentralization, and security. You push one too much, and the others start wobbling and gobbling. That's the trilemma. So you see here, we have three pillars, three major points that we need to take care of: scalability, security, decentralization, and we can only get two on three. Now, the thing is, we do not, please understand and know, we do not have any single golden solution to this trilemma. But because solving it is so much critical for the blockchain's future, the blockchain community is experimenting with different approaches. Key methods involve sharding, different consensus mechanisms where we learn about how we're moving from proof of work to proof of stake, and even more innovative models like delegated proof of stake and many more. Then we have layer 2 solutions where we'll talk about the side chains, the state channels. So each of these will bring promising results as you will see ahead. But the perfect balance is still a work in progress. And that's what makes the blockchain trilemma such an ongoing area of innovation. Let's come to the first solution to the challenge, that is sharding. If I talk about sharding is one of the most popular solutions that we have to the scalability problem. Let's think of a blockchain like a very, multi-cuisine, busy restaurant, and it has just one kitchen. You make any order, every single order, it how big, how small, whatsoever it is, veg, non-veg, it has to be cooked in that one kitchen. And naturally the kitchen gets overloaded and the service slows down. What is sharding? Sharding is like splitting that one big kitchen into many smaller kitchens. Each smaller kitchen or shard handles only a portion of the orders. So instead of one kitchen handling thousand orders, now I have one shared kitchen holding 100 orders. Much faster, much efficient. This is what actually happens in blockchain. But in what terms? The network is divided into multiple shards. Each shard maintains its own ledger and processes its own transactions independently. But then how do they account for all of them together? Then I have a main chef sitting. You can call him the bacon chain or the main chain. He coordinates between all the kitchens, between all the shards of the network, making sure everything stays in sync and secure. So this way, no single blockchain has to carry the weight of all transactions. Since, sharding is actually changing up or is actually making some changes in the main blockchain itself, in the foundation blockchain itself, it is considered to be a layer one solution. Unlike some add-on solutions, state channels, side chains that we'll study as we move ahead. So yeah, sharding allows a blockchain to scale massively without giving up on decentralization or security. It is one of the promising solution to the challenge. Then let's come to the different consensus mechanisms. Another big reason the trilemma exists in the way blockchain reaches consensus, right? Because consensus is what I need from all the nodes in the network who are participating, right? And I have to agree on which transaction is valid, because once I have appended a transaction in the blockchain, I cannot make any change to it. I cannot just pop that transaction off anyway, you know. So Bitcoin, for now, it uses proof of work consensus. Miners compete here to solve the complex puzzles using huge amounts of computing power because the puzzle is tough. It is hard puzzle to solve, given that we do not want to expose our vulnerabilities for security. So that's why Bitcoin can only handle, 7 transactions per second. So to solve this, we have new consensus mechanisms coming up, and a popular one is proof of stake mechanism. What happens here is, instead of buying expensive mining machines, solving the complex puzzles straight away, participants simply stake or lock in their tokens to become validators. The more tokens you stake, the higher is your chance of being chosen to validate the next block. The approach, is going to have actually has some major benefits, which goes for it removes the need for energy hungry mining hardware, allows more validators to come in, join the network. Most importantly, speeds up the system, making it more scalable. And yeah, Ethereum switched from proof of work to proof of stake in its big upgrade known as the merge upgrade. And yeah, proof of stake is not the only option. We are still innovating, still on a path to innovate more and more. We have many other mechanisms like delegated proof of stake, proof of authority. So yeah, experimenting with new consensus mechanisms is one of the most promising ways that is happening right now to tackle and to keep tackling actually with the blockchain trilemma. Then let's come next to the layer 2 solutions. So now we've already seen about how the layer 1 solutions like sharding, new consensus mechanisms tried to fix the blockchain trilemma, right? So let's assume I have a very busy road, right? A very busy road. Everybody is going to their office. There are no work from homes given, right? And then the traffic is like on the next level. So one idea is to have proper traffic lights and everything to reduce accidents and everything. That is the first, that you change the layout only, that you make changes to the foundation. That is your layer one solution that we talked about earlier, that go with different consensus mechanisms, that is using proof of stake over proof of work. Then also sharding. This is also layer one. Then also, and the second way is I build an expressway over this busy road. I build a highway or I build an expressway that links two places, but that is through a highway. So if I do this, this is called layer 2 solution. And in layer 2 solution, you're going to learn about your side chains, you're going to learn about your state channels. So that is how it's done. Okay, let's talk about the side chain. A side chain is what? Side chain is basically another separate blockchain that runs alongside the main one. Why is now, how does it even give you benefits? Assets. What I mean by assets, tokens. Tokens can move back and forth between the main chain and side chain, and the benefit is that the side chain can have its own rules. Maybe it can process transactions faster, cheaper than the main chain. And then let's come on the state channels. So let's imagine you and I are playing a game of chess. Normally, if we have to record every move, every pawn that I move, or every the element of your game that you move, we keep recording it. Slow, expensive, right? But what if I say all our chess moves will happen privately between us off the chain, and whenever the game ends, we'll just record the final result on the blockchain? That is what is a state channel. You know, we just because we need to record our transactions, we will keep all the records of transactions independently. We'll move them privately between us. We'll open a state channel with smart contract between us, and we'll not be publishing, all transactions that happen between us. We will just ask the blockchain to record the start and the end of the channel. Correct? That is it. So in short, you understood that layer one is just like fixing the main highway itself, sharding, new consensus mechanisms, and layer two is like building extra roads on top of the highway. Side chains, state channels, right? Yeah, with this, I think I'm good with it. Thank you, everybody. If this content vibed with you, if you understood, if you even could take, 5 to 10% of the life, 5 to 10% of the content, or it made your life 5 to 10% easy, hit like, hit subscribe. And if you have any concepts that you want me to take next, uh, you know, any subject that you want me to take in next, use the G form link given below, use the comment section given below. And yeah, I'll try to approach to it as soon as possible. Thank you so much.